All right, I'm going to try to do this in one video, meaning I'm going to answer these from yesterday and then switch to showing you on the board the next material. Okay, so we're going to try this. Don't get dizzy on me. So this first one that you did, I already worked out, like, remember you move the 3 first. That's the first step. You get 12. And then you've left with 3x. Your second step is to divide both sides by 3. You should have got x is 4. Okay. Number 2, same thing. You move the 7 first. Okay. You're left with 4x on this side. And on this side, you're left with 20 now. Then you divide both sides by 4 is your second step. And you get x is 5. Okay. This one I switch places, but all you do is move the 7 first still. And don't forget that this is a negative 2x. This is 8. And now you got to divide by negative 2. So you can get rid of the whole thing. And positive divided by negative is negative 4. Okay. Here is a 2-step. And this is not part of the fraction, so we can easily move it. And so we're left with the fraction still. But over here we now have 5. And then instead of dividing by 3, we're going to multiply by 3. X is 15. Same thing here. We can move this 3 first. And we get y over 5 is 15. And then we multiply both sides by 5. And we get y is 75. Okay. Here, now I can't move the 3 because it's part of the fraction. So the first step I'm going to do is get rid of this bottom 3 by multiplying it. But I got to multiply this side by 3. So I'm left with the top of my fraction. And over here I'm left with 30. And then I can move this 3. So y is 27. Okay. Same thing here. I can't just add the 7 because it's part of the fraction. But I can get rid of the 2 by multiplying it. So I'm going to multiply this by 2 as well. And I'm left with just the top of my fraction. And here I get 10. And then I move the 7 now. Okay. So that's the order to do those, the easiest order. And so check your answers. Go through and practice the ones maybe you missed and check them again. I know it's not a lot of problems, but it would be good to maybe run through them again if you missed a couple and check that. The next thing we're going to look at, okay, and this is where I was really kind of hammering that we're going to try to keep the variables on the left side. It just makes this part easier. It's not that you have to. You're going to see why. But so far, all the problems that we've done, even the 1-step and the 2-step, there's only been one variable, meaning, if you had an x, there's only one of them. And so, we just isolated that and solved. Some of them got longer, as you got to 2-step, and you can actually have multi-step ones that go on a long time. But I want to look at what happens when you have variables on both sides. Now, we're still talking about the same variable, though. So it's not going to have like an x and a y, because that gets into deeper algebra where, you've got to substitute and go and do several things. This is going to be like an x on one side and an x on another, not an x and a y on the other side. So we're still talking about having the same variable, but now we have them on both sides of the equal sign. So that would look something like this. Okay, and they can look all different. We're going to do several different varieties, but here's one of them. So where this is different than the ones we've been doing is we don't just have an x and then all numbers. We have an x over here, and then we have a variable on this side. Okay, so we still have to isolate the variable. That's still always going to be our goal, is to get the variable alone. But our first challenge is, well, we got a variable over here and a variable over here, so which one do I isolate? Well, that's why I told us we're going to work with always moving our variables to the left side. It just makes it easier. You don't have to, but I think for us right now, as much as we're condensing things into certain days, this is kind of the way to go. But we still have our fence here, okay, so that equal sign is still the fence. And I want to start with getting my variables to this left side. So that means I'm going to move this 2x over here. Now, before, you think, okay, well, I'm going to divide by 2, right? That's what we've been doing instead of multiplying. that's only if I want to move the 2 and leave the x, you know, isolate the x. I don't want to do that. I want to move this whole thing over here, which means I want to get rid of it here. So how do you get rid of anything? Take it away. Instead of having 2x, subtract it. Okay, so that way it cancels out. But I did that to this side, so I got to do that to this side. Now, if you have, don't think of x as a, you know, don't necessarily think of it as some weird thing or something. Just think of it as like having something in your hand. Or I walked into a store and they had 5 xylophones there, and they got rid of 2 of them. They sold 2 of them. Well, that means in their inventory, all they have left is 3 of them. 3 xylophones. If you had 5 xylophones and you got rid of 2 xylophones, you now have 3 xylophones. Okay, so that's what you do there. You still have your fence. Okay, see, these canceled out. See, that'd be like having 2 xylophones and you took away those 2. Now you have nothing. So that did away with that. So we still have 9. Well, now that looks familiar. 3x equals 9. Now all I want to do is, now I want to get rid of just the 3. I don't want to subtract 3x and get rid of everything. I want to divide by 3 so that now I have just x, and I've solved for x. And see, I can plug this back in still. You can always plug it back in. Let's check this. Every time I see x, I'm going to plug in a 3 in, and we're going to see if this comes out the same. So 15 equals 6 plus 9, and that is true. 15 equals 15. So that's, you know, every time I saw an x, I plugged in a 3, and it still comes out correct. Okay? So that is, you know, the first little introduction of what happens when you have a variable on both sides. Now, they are going to build from that. So let's say you've got, let's say it looks like this. I'm going to put a variable and a number on this side and a variable and number on this side. So it's a little bit different because the last problem just had a variable, didn't have a number. Now, first thing to look at is I cannot combine these. This is called like terms. And I know we didn't hardly spend any time on that, but this has a variable, this doesn't. I cannot just take away 3 from 4y. It's like saying having 4 yo-yos and you take away the number 3. Not 3 yo-yos, just the number 3. You can't do that. So I can't combine these two things. I can't, you know, I can't make it 1y. Now, if it was 4y minus 3y, that's different. That's 4 yo-yos minus 3 yo-yos, so you have 1 yo-yo. But this is not the same. So I cannot combine it. Same thing over here. This is a letter, this does not, so I cannot combine those. But what I can do is the same thing we did over there. We're going to move this over here. So we're going to take away these 2 yo-yos. Okay? We're going to get rid of it, and we're going to move it over here. Okay, so if I had 4 yo-yos and took away 2, I have 2 yo-yos left. Now I still can't combine it with that negative 3. It's funny saying yo-yos that many times. I still can't combine that. I've not moved it yet. And now over here I have 7. Well, once again, now we're familiar. This is a 2-step problem now like we did yesterday. Now I can move my 3. Because remember, your goal is to get this isolated. So now I've gotten rid of that, and it's over here. And now I want to get rid of the 2 by dividing. So y is 5, okay? If you plug that in, you can check. 4 times 5 is 20. 20 minus 3 is 17. Same thing on this side. 2 times 5 is 10 plus 7 is 17. Okay, so 17 equals 17. So that's solving for, the only thing y can be to make this true is 5. It's the only thing you could plug in to make this a true statement. That's what you're solving for. Okay, let's try another example, and let's make this one a new little wrinkle. So 6m minus 2m plus 4 equals 3m minus 10. Now I know this looks scary, especially as fast as we're going. But always, always remember your goal is to get just like m over here equals a number over here. Okay? Trying to get the variable by itself equals something. Now, there's work to do, and we're going to have to move stuff, we're going to have to do stuff. The first thing you want to do, though, is if there's, now remember, this is a fence, so you're going to work on this side of the fence first and see if there's any work you can do, and then check here and then start mixing. In this case, you can subtract these. because these are like terms. This has an m, this has an m. There's only one of them, meaning it's not squared or anything. So 6m minus 2m, 6, what's a funny word? Well, 6 machines minus 2 machines leaves me with 4 machines, okay? And then I can't combine the 4. This is not a machine. This is over here still. I can't combine those two. So the first step was to just combine these and make that smaller. Okay, now I look and say, okay, there's nothing else to combine. Let me get the m over here. I'm going to take away these 3 machines and move them over here. Now what happened was 4m minus 3m leaves me with 1m, but we don't write 1m. If you did, that's fine, but it's just 1m. I still have my plus 4. Over here I have my negative 10. As you can see, if you always move to the left side, then you don't have to question where you're moving things. You always get your variable over here, you always get your numbers over here. Now all I have to do is move this number over here, and I have m is negative 14. Okay? All right. One more that I'm going to make really long and just freak you out, but I promise you, if you just keep going back to the main goal and really center in on what you're doing, it does become easier. Don't get thrown off by letters and numbers. Just remember what your goal is. To get your letter over here isolated, get your numbers over there. Now, I can combine a few things. I can combine 5x plus 3x. It doesn't matter that they're in a different order. I can go through and say, hey, if I got 5 xylophones over here and then I'm adding 3 more, I now have 8 xylophones. And another thing I can do is say, well, I can do 8 minus 2. Okay, these are like terms. They're not x's, they're just numbers. So I can do 8 minus 2 and get 6. It's a positive 6. Okay, if it had been a negative, I would have made sure I put minus 4, something like that. And then over here, there's nothing to combine. So there's nothing to do on that side of the fence. This side I can combine these two. This side I can combine these two. And so I did that. Now the problem looks a little bit easier, maybe, I don't know. But now I want to get this over here. I want to get the 9x over here. So let's move it. And what is 8x minus 9x? Well, negative 1x. And we don't need that 1, so it's just negative x plus 6. That never went away. And over here, all I'm left with is 10. Okay, now all I need to do is move the 6 over here. Okay, and remember, we don't leave it negative. We put the negative on this side. So x is negative 4. Lots of stuff, I know. Go back through, watch those again, go through them slowly, check them. Another thing you could do is look up variables on both sides, like Math Annex is a good one, Khan Academy, and get some more looks at it. Different explanations sometimes help. And so that's variables on both sides. If you type that in, you'll get plenty of videos and help. Okay, so that's one thing. Let me put up an assignment for this. So I'm going to have you try these. Okay. So number 1 is 3y equals y plus 6. Remember, this is, if it's just a y, it's 1y. Number 2 is 5x minus 10 equals 3x plus 8. Number 3 is 5m minus 2m plus 7 equals 2m minus 10. And number 4 is 6x plus 6 plus 4x minus 3 equals 8x minus 3. Now this last one, remember, combine what you can over here and then start your process of moving things, okay? So try those, and we'll check them tomorrow, okay?